Hey, hello. This is 9.4 Compositions of Transformations. In this section, you will be using all of the tools that you learned from 9.1 through 9.3 to work on your transformations themselves. So everything that you've done with reflections, rotations, and translations thus far, you're going to be using here. So let's start with your warm-up for today. So the first thing that you should notice is that you've got a translation. So when you're translating, it means that you're moving. So the vector in this case, since you're moving 3 units to the left and 1 unit up, so your vector should be 3 units to the left and 1 unit vertically. So that means that your brand new piece, your brand new coordinate, here, if I take 4, -7, and I translate it thus, then 4 minus 3 is 1, and -7 added to 1 is going to give you -6. So that is your new translated coordinate. For number 2, you have a rotation of 90 degrees about the origin. The key here is to remember when you have a rotation, unless you're told otherwise, you are to assume counterclockwise. So this is going to be a counterclockwise rotation, 90 degrees. So when I'm moving 90 degrees, so if you think of your coordinate plane, so 4, -7, so when I look for 4, -7, it should be here in quadrant 4. Therefore, a 90-degree rotation should be in your first quadrant. So knowing that your 90-degree rotation is going to be in your first quadrant, okay, so your rotation rule here is that you are moving 90 degrees about the origin, therefore you're going to change or swap your values of x and y, and you're going to use the opposite or inverse of y. So that means that your coordinate this time around, you know, since it's in the first quadrant, it should be a positive term and another positive term. So your y coordinate was -7, it is now a +7, and your x coordinate was +4, and it remains as +4. And then finally, you are making a reflection over the y-axis. So when you reflect a coordinate, remember that was from section 9.1, the axis that you're reflecting over is the term that's going to stay the same. So since I'm reflecting over the y-axis, my y-coordinate is going to stay the exact same. So it's still going to be -7, and I'm going to use the opposite. So it's the opposite of x. You keep y. So the opposite of +4 is -4. Okay, so today we are working on our composition of transformations. So the goal at the end of this class period is to make sure that you not only can identify and draw the different compositions, but also that you are able to understand the word isometry as it relates to these different objects. So I know that we went over that in 9.1 briefly, but you're going to see a little bit more of that today. Okay, so we're looking at compositions of transformations. The word composition itself means that you are putting more than one object with another. So here, our transformations this time are composed of both translations and reflections. So that's where we get the term glide reflection from. So when you've got both of these transformations happening, then you know that you are going to have a glide reflection. So that's an important word. You want to make sure, hint, hint, wink, wink, that you get that down. So your glide reflection here, you're going to be making your translation and then reflection. So that's all that this slide is showing you here. So your original triangle, JKL, so here your original triangle, JKL, moves along this vector, V, and shows that you're translating over. So that's what you learned in section 9.2. So from section 9.2, then we're going to look at what we learned in section 9.1. We're actually reflecting our translation. So if we were to label that second triangle, so the first translation would be our first prime, and then our second, where we reflect, is going to be our second prime. But here, since we wanted to make a glide reflection, you can use that second triangle, that translation, as a point of reference for yourself, but ultimately you want to end with your triangle here. That's your final reflection. So one of the reasons that the composition of transformations probably looks familiar to most of you is because in about 6th, 7th, possibly 8th grade, your teachers talked about the transitive property of equality. So that's similar to what we're seeing here, only we call it the transitive property of congruence. So you might remember when you had term A is the same as term B is the same as term C, therefore term C and A are equal to each other. Okay, it's the same sort of property. So this time what they're saying is if my original is the same as the copy, so if my original is the same as the copy, so the preimage is the same as the image, and the image is the same as its image, then that means that all three must be the same. So if those two are equal and these two are equal, then I can just cut out the middleman, and that these two are also congruent to each other. Okay, so we've reached our first example. So our first example, they give you triangle JKL and they give you the vertices for each. What we're going to be doing is a two-step process. So the first thing that they've asked us to do is to reflect triangle JKL across the x-axis. So we know from section 9.1 that when we reflect across the x-axis, our rule becomes to keep the value of x and change the value of y. Okay, so first, that's what we're going to do with each of these coordinates. So J, K, and L are all now going to be images of my original triangle. So I'm going to keep my x coordinate and change my y coordinate. So for each of these, J had an x coordinate of 1, K had an x coordinate of 4, and L has an x coordinate of 3. So nothing has changed there. And the only thing I'm going to do for my y coordinate is change that value to the opposite. So negative y becomes a positive y on this first piece. So you've got negative 2 becomes a positive 2. For K, now K prime becomes another positive 2. And then L prime is going to still be 0. So, but that's not all. From here, you are asked to then rotate it 180 degrees about the origin. Now remember, if we're not given a direction, then we automatically assume that we are moving counterclockwise, we're rotating counterclockwise, but because it's a 180 degree rotation doesn't matter whether we're moving clockwise or counterclockwise. Our rule is still the same. So our rule this time around is going to find the opposite of our x coordinate and the opposite of our y coordinate. So what I'm doing is finding the image of the image. So if I relate it back to our original, I'm finding double primes this time around. So what I'm doing is I am rotating my image. So I'm using the coordinates that are here. So J double prime becomes negative 1, negative 2. K double prime becomes negative 4, negative 2. And L double prime becomes negative 3, 0. So now that we've got these new points, we are going to graph them. So when we graph each of these points, so our first being negative 1, negative 2, our second, K prime, is now negative 4, negative 2, and finally we've got negative 3, 0. Okay, so we will connect our dots here, and we're going to make sure that we label our terms. I realize that my points are off a little bit. So J prime, because I didn't actually include the reflection, we're not creating that second triangle. We're not creating that original first image. We're creating the second. So that's our new image. So negative 1, negative 2, we're going to consider that as J prime. Negative 4, negative 2 will be considered as K prime. And L prime is at negative 3, 0. So now we've got our answer to our question. So we're learning about composition of transformations, and while we're learning about composition of transformations, there are a couple of theorems that you need to be aware of that will help you in the long run. So the first being our theorem based on our reflections and parallel lines. So when you have two reflections based upon a parallel line, a set of parallel lines, then you know that from your first pre-image to your second image, it is considered a translation. So do you see how from your pre-image to your original image, it was a reflection, but then a reflection of a reflection for that second image became just a translation? So that's what they're saying there. The composition of two different reflections is really a translation, and that relates back to the transitive property that we were talking about. So then, you've got the composition of two reflections when you have intersecting lines. Now, intersecting lines mean that when you have a reflection of a reflection, you're really going to have a rotation. So you can see again how from your pre-image to your image, you reflected over your original line of reflection, but then as you reflected over that second line of reflection, the image of the image is actually a rotation of the pre-image. Tabitha here has an image that she wants to reflect twice. So you can see her, she's reflecting across line N, and then she's going to reflect that image across line P. So she's double reflecting. And from the theorem that we just looked at, we know that from the pre-image to the second image, it's going to be a translation. So, but just in case, let's check it out to make sure that that's where we are. So, initially, and I'm only going to work with the outer piece here. Okay, so I'm only working with the outside ring of this image, or pre-image that we've been given. So then, if I reflect across line N, and then I take that image, and I reflect that image across line P, then you will end up with a translation. So from your pre-image to your second image, that's a translation. So not only is it a translation, which is what they want us to describe, we have to describe how that translation is happening. So yes, I'm translating across parallel lines. So, but when you translate across those parallel lines, do you see the distance here? So they've told me that it is a 3-inch gap between line N and line P. Therefore, I can assume that there's another 3-inch gap between line P and the base of my figure. So I can say that that's a translation by a distance of 6 units. Okay. And I apologize, my students, you know my handwriting is not the best. So you're translating 6 units. Theorem 1243 tells us that anytime we have a translation or a rotation, it is comprised of 2 reflections. So again, just to refresh your memory, so we know if we have a set of parallel lines, so if we have a set of parallel lines, and we're going to mark them parallel, okay, or if we have intersecting lines. Okay, so a reflection of a reflection has a special name. So on that first component there, so let's say we had a triangle. So if I reflect over my first line of reflection, and then I reflect over that second line of reflection, your image of the image is your pre-image. So again, we're cutting out that middleman. That's what that tells me. Okay, and so that would be a translation. So that shows you how you were able to comprise that translation of your reflections. So the same is true when you have intersecting lines. So here, if I were to reflect this triangle, so this pre-image, over the line of reflection that I created, so there I've got my first reflection, and then a reflection of that reflection. Okay, that image I can see has been turned. So let's give that a point. Let's call that point N up at the very top. So when I moved point N when I reflected, is still facing up at the top, and we talk about the compass a lot in my class. So north, south, east, and west. Okay, so if point N was facing north, and now in my reflection of a reflection, N prime down here is facing south, then I know that because I moved opposite direction, so there, that is a rotation, because I'm not facing the same direction that I initially was. If you're in Miss Moore's class, then you already have your workbook, so you can go ahead and turn to workbook page 392. If you do not have a workbook yet, then that is fine. You're still able to figure out what your lines of reflection are going to be here based on the pictures that are on the slide. So our goal here is to draw in two different lines of reflection. Those two different lines of reflection. So we just learned on our theorems that when I have double reflection, that's actually a translation. So if I look at number 1, that's based off the first theorem that we just learned about. So for number 1, I can draw in a few lines of reflection. So the best thing that I would do here is between C and C double prime. C is at 3 vertically on your y-axis, and C double prime is at -5. So you want to find out what is the distance between those points. So there, that's a distance of 8 units. So since I've got a distance of 8 units, and I want to make sure that I'm able to split. So if I'm able to split 8 units evenly, then 8 cut in half should be 4. So that means that my lines of reflection should be 4 units apart. So if I were to draw in my first line of reflection here at the line y equals 2, then I could draw in my next line of reflection at y equals -2. So remember, since these are lines, we want to show the proper notation on those lines. So those are my two lines of reflection. And if you draw straighter than I do, which I hope most of you do, then you should have parallel lines there. So luckily the coordinate grid helps me out with that a little bit. So then when we get to our second picture here, so we're trying to draw in our lines of reflection. So in between your original, which is ABC, your original pre-image, and then your image of the image, so your double prime over here, I need to figure out just what distance I have between B and C, or B and B double prime, so either way. So we want to try to split the difference again. The best thing that we can do is attempt to work backwards on this problem. So you have your image of the image, so we're going to work backwards from there to help us out. So if I am reflecting, or the image of the image is a reflection of my original image, then we're going to go ahead and try to draw in that center reflection. That way it'll help me out a little bit. So I'm going to choose to consider my y-axis one of my lines of reflection. So we're going to go ahead and draw in that line of reflection. Okay. So that's going to be my first line of reflection. And if that's the case, that means that my original image should have been a true reflection of that double image, the image of the image. So we're going to go ahead and draw in that other image. So when I manipulate the points, so currently the image of the image for B is 2 units beyond the y-axis. So that's going to be true when I work backwards for the reflection. So, and then, let's fix that a little bit. Okay, so I'm going to work backwards here. Then, again, for A, you were 3 units away from the x-axis. So that means that you were on x equals 3 over here. So you're at 0.37. So now I'm going to be at -37. Then C actually isn't going to change for us. So we're going to go ahead and, just like in kindergarten, connect our dots. So here you have A, B, and C, but that's your original prime unit. So if I want to figure out then where my next line of reflection is, then I need to look at my image versus my pre-image. So your image versus your pre-image, we are going to go ahead and draw in another line of reflection. So here, there's approximately 1 unit of space in between those two. So it looks as though our line of reflection is going to be here. So at y equals x. So you've got your 2 lines of reflection, and it just so happens, ta-da, that we have our 2 theorems that we had just talked about. So this is how you can utilize your workbook to help you out. Your lesson quiz for this section. So these are the 3 questions that we have expected for you to answer after you've taken your notes on this section and for you to have as soon as you come into class for our next class period. These 3 are all based on the composition of transformations. So those first 2 are both based on PQR. So since there's 3 vertices, we assume it's a triangle. So triangle PQR, that's where both 1 and 2 are based. And then for your third figure, actually, you know what? For that third figure, I want you to go ahead and attempt it. So use the online textbook, and I want you to attempt that problem. But we'll start with that problem when you come in for class tomorrow, because I feel like it'll be much better for all of you if you see us work with that figure on the board. Your assignment for tonight is page 633, 1 through 13. And I misspoke. Your assignment for tomorrow during class time is page 633. And then for those of you that have your workbook, you want to tear out 393, 394. That is what you are going to make sure that you have with you in class. So do not forget either of these materials. Now that we've reached the end of lesson 9.4, don't forget to rate yourself. So Mr. Patrick, your link for your class is on the left-hand side, and then for Mrs. Moore's class, your link is on the right-hand side. You can use a QR scanner. If you have yet to download one, Red Laser is a free QR scanner, so you can always download that. If not, then Mr. Patrick has the Google address there, and then for my class, you can always copy that QR code, and you can use a QR code reader on your computer. You can just Google one. So if you need anything, please be sure to leave us your feedback so that we can make sure to get you all of the assistance that you need.